A bob of mass m is suspended by two strings as shown. Find T. How do it oscillate? The plane of oscillation will be perpendicular to this one. No, not like this, huh? Perpendicular to plane. So it is slightly displaced into the plane of paper and release. Find the time period of oscillations. So not in XY plane. Suppose we'll define XY plane here. So in which plane it will be? The plane of oscillation is not XY plane, will be YZ plane will be the plane of oscillation. So it should be like into the plane of paper or plane the oscillations will be. So now plane of oscillations, try to remember, not XY plane. YZ plane will be the plane of oscillations. The plane of oscillation. They will explain if the bob of mass is suspended by two strings, I should find the time period. If it is, I'll write it better. If it is given, small displacement perpendicular to plane of triangle. I think more than this information will not be there. The plane of oscillation will be YZ plane. For your understanding purpose, the plane of oscillations will be YZ plane. Okay, what is actually basic idea? So we have to search for the effective length. That's all. So this effective length has to be determined, or why I'll write it. Okay, how to bring that effective length? So call this is x1, this is x2. We know x1 plus x2 is 7L and right angle triangle 3 root 2L whole square plus x2 square equal to y square. Similarly, 5L whole square equal to looking at the triangle, so 5L whole square should be equal to x1 square plus y square. Two equations, two unknown are there. Solving these two, what happen? Solving these three equations, x1, x2 will get it. After getting x1 and x2, we can calculate y. From y, we can go for effective the length. So what is the time period of oscillations will be 2 pi y by j. So now this is the effective length of the pendulum, not this 3 root L or 5L. Sir, what happens if I displace in xy plane? No, then this will become loose. Then it cannot be not possible for it to be oscillation if I displace it. I'll try to explain. Yeah. So it cannot be like this. The oscillations are not like this. Are you getting? The oscillations are okay. To some extent, with the help of the graphics I'm showing it, try to understand. So the oscillations are not like this. Okay, fine. The oscillations are perpendicular to the plane of diagram. So then what is the effective length of the pendulum? Then this y only. If I displace like this, what will happen? This string will become loose, the right 3 root 2L, the right string will become loose. Then by the time it comes out, then impulse will come. Due to impulse, again, not possible. It cannot oscillate. It can oscillate like this. Getting some picture? Hmm? Okay, now how to get x1 and x2? I think solving these two. So first, let me equate this one. This will be 9, 18 L square equal to x2 square plus y square. 25 L square equal to x1 square plus y square. Equating these two will get x2, x1. Then we have one more. Solving this will get expression for anybody value of y? Y equal to 3L. Okay, very good. Yeah, y equal to 3L. So what is the time period? I think what is very important, that particular oscillation in which plane it is oscillating. That is very important. I think until unless if you don't have that information, I think it will be very difficult for you to really to think on a problem. Okay, similarly, we'll take one more. There's a light rod. There's a wall. So I'm bringing another, the pendulum only in this way. So let this be the, here is a bob. This is a bob. So this particular thing, the rod is hinged such that it can rotate in all the directions. Okay, I'll put it. The bob is slightly displaced perpendicular to the plane of the rod and string. Find the time period. Small oscillations. Okay, I think so. The bob is slightly displaced perpendicular to plane of, and the rod is hinged here. This is hinged. It can rotate in all directions. Okay, the string, what's happened? Will it permit it to oscillate like this? And we are not understanding what actually this oscillation and how it will be. Okay, let me try to explain with the help of this. Okay, I think all of you are able to see this. Now, will it oscillate like this? Will the string will permit? String is inextensible, no? So string will not permit. Are you seeing the blue color one? This red color and this bob is there. So it cannot oscillate. Any reason for that? Because the string is inextensible, not possible. Can it oscillate? I think I'm able to show very systematically the thing, that one. So the bob is displaced perpendicular to plane, slightly displaced perpendicular to plane of the rod and the string. So I think this is justified. Not like this, sir. Not like this. This is the wrong thing. And it cannot go like this. This is also not possible. So it should be like this. Sir. But it should not be vertical, not in XY plane. So again, it is in YZ plane. is asking to calculate the time period of oscillation. All of you able to understand? So this rod, this what happened? This rod can rotate like this also, can rotate like this also in any plane. In all directions, it can rotate, but the string will not permit it to swing like this. Not possible. If there was a spring instead of string, okay, it would have been. But here, what happened? It's a string. Let's have a diagram like this. So you should imagine. So just take the pen, pencil, something, and you should able to imagine on your own. Okay, let me do one thing. Let me call this O. Let me call this is P, Q. Okay, let this be R. So if one diagram, the rough way. So we can also think in this way here. The string what will happen will take this particular angle. So slightly at this place. This is what the theta. This is what Q. Earlier this is P, no? Now the P will come to this position. I'm just showing some diagram so that it'll be the tension here will act like this. T naught, you can write it. Component of tension, from where the restoring force will come, the component of tension will act in this direction, and that will make the rod plus bob to rotate. There also G is there. And there'll be also torque due to the weight also will come. So torque due to weight and component of tension. Okay, still sir, like how we can really find out all these things. So what is the, in terms of length, only what is the information we have? Length of the string is L, length of the rod is 2L is what given. And at the midpoint of the rod, the string is connected. You may end up diagrams of this kind where a student has to make some small observation, nothing big. Let me show this diagram. I'll magnify. So in this diagram, we'll try to work out. Okay, this much is available. So let's take the condition like this. No. What to do for this? This is the about OQ line. It's going to execute SHM. So there is a reference. This is a string. No? So this is like this. The about OQ, what happened is going to execute SHM. It will be. So then this will become effective length, and you resolve G also. This is G, no? So the effective G will come like this. Okay, let this be theta. This will be theta. So what is sine theta? Effective length is needed, no? So sine theta equal to L by L dash equal to L by sine theta. Theta is 45 degrees from the triangle. So this will become L dash What about G dash? G dash should be equal to G cos theta. Should be G by root 2. So the total time period is given by, let me wind up here only. Next page. Okay, let's take this. So what is the effective time period given by 2 pi L dash by G dash. So what is L dash? L root 2, G is G by root 2. So this will become 2 pi 2L by G. That will be our answer. You have to search for that particular thing. So there's a bob. So it's going to execute SHM into the plane of paper. That's the major thing. And the rod water pen will remain in this particular plane. I'm just showing the diagram. The string will take this particular position. Okay, this theta will get confused. Component of tension that is acting on the rod or the pen will become like a restoring force.